Alright, in this video segment we're going to be looking at mining, focusing on mining and minerals, different ways we can mine for these minerals, some examples of these minerals, some of the big ones we mine for, and what the difference between minerals and ores are. So as far as vocab goes, mineral versus an ore. We know a mineral is any naturally occurring substance that has a definite chemical composition. Example like quartz. Quartz would be a type of mineral. Feldspar would be a type of mineral. We would even mine for metal minerals, minerals that are actual metal in chemical composition, like gold, silver, those types of examples. Getting into fossil fuels a little bit, we're going to mine for those types of materials as well. Coal being a big one, natural gas, petroleum. Okay. Ore, on the other hand, ore is a type of rock that contains minerals, like metal minerals, that we're going to extract through mining, and then we're going to put it through the refining process to separate the unwanted rock from the metal or the mineral itself. For example, our biggest metal that we're going for is going to be gold, as far as the most valuable to us. And the way our biggest gold mining operations work is they're actually mining for gold ore. It's going to be a type of rock that contains small, almost sand granular size particles of gold. This rock will, this ore will. Usually gold ore is going to be made up of these fine particles of gold, and you can't actually see the gold within the ore itself. And then it's also going to be made up of carbon. That's going to kind of give it maybe a grayish look to it. Maybe in some other stuff as well. Maybe it has some silver in it and those types of things. That would be an ore. And then what they would do is they would extract that gold ore through the mining process, and then they would refine it. They would melt it, and then they would remove the unwanted carbon and other rock that forms around it, and then what's left over is just a melted gold itself. So mineral versus ore. Another term we know, mining, is just the process of removing useful materials from the Earth's crust. Four major operations that usually go on when mining is going to occur. And usually in this order is what you're looking at when you're before and while you're going through the mining process. First of all, you got to make sure that you find a particular mineral deposit that you're wanting to mine for. That's going to be prospecting. Then you're going to go through the exploration part, where you're going to assess the size, the location, the amount of that mineral deposit in question, how much money it could bring you. So that's assessing the actual shape and location and economic value. And then you're going to develop it. You're actually going to prepare to access that deposit, get all of the machinery and materials in place, and then go through that exploitation process, which is the actual work of extracting minerals from the earth. There are categories of mining. The two major categories are going to be surface mining and subsurface mining. Surface mining is the most common type of mining because it's easier, it takes less time and energy for surface mining. Subsurface mining is going to use different types of shafts to reach different locations underneath the earth, and then once it gets there, then you're going to usually use some type of blasting process to extract and excavate the mines underneath the ground. Let's look at surface mining. Focus on some examples of it. You have open pit, strip mining, and mountaintop removal. Those are the types of surface mining. For open pit, you're going to be cutting deep holes into the ground, removing those layer upon layer of the Earth's surface until you get these large holes. And while you're doing that, you're extracting the area that you develop to make sure you know where that particular mineral is going to be found. Strip mining, you're actually removing just strips of the topsoil, okay, because the mineral in question that you're looking for is found mainly in the topsoil, so you'll strip it, not necessarily removing large swaths of soil, but just strips in a particular area to remove mineral. And then mountaintop removal. Now when you're going through these processes of mining, you're going to be looking for minerals, mineral deposits, or ores, and you're not going to be able to just remove the mineral or the ores themselves. You're actually going to be removing all of the soil and the different types of soil, whether it's gravel or clay, topsoil, rock. You're going to be removing all of this stuff where the mineral is located. So all of the excess stuff that you have to move along with the mineral to get to the mineral, that stuff's called overburden. So overburden is just that excess waste rock and soil that you don't want, but you have to dig it up to get to the mineral itself. Picture of an open pit mine in Utah, deepest mine in the world as far as open pit goes. This is a copper mine. Here you have an example of what a strip mine looks like. This is one in Kansas. It's a coal strip mine. It's not being used anymore. They've actually tried to convert it into like a wetland type area. And then mountaintop removal. So those are just three examples or three pictures of the types of surface mines that you can get into. Now, subsurface, below the Earth's surface, you have three ways that you can do a subsurface mine, and it has to deal with the angle and location, how deep you need to go. If it's just barely below the Earth's surface, but it's far enough down to where you need to actually do a subsurface mine, you can get a drift mine, which is going to say you're at the side of a mountain and you don't want to remove the whole mountain, but you need to go into the side of it, maybe towards the base. You can get a drift mine, which digs a horizontal tunnel, access tunnels into the site that you want to blast, and then they'll use a dynamite, ammonia-based, maybe even nitrogen-based materials to blast and then remove the materials that way. If it's a little bit deeper, you can get a slope subsurface mine, and then the most common, when we think of subsurface, the most common would be a shaft mine. It's going to be a vertical tunnel drilled into the earth, anywhere from 500 feet to 2 to 3 miles. The deepest one on the planet is 3 miles down in South Africa, in Johannesburg. And then once it gets to the distance it needs to go, then there will be those horizontal access tunnels from there where they'll do excavating and the blasting sites and those things. Here's a good picture that you have in your notes. Gives you just a snapshot of a shaft versus slope versus drift mine, and then on the other side you can see the surface mining, whether it be open pit and so forth. Now, when we're talking about mining, the most valuable commodity that we mine for here in the U.S. is coal. We have more coal. We have more coal reserves than anyone else on the planet, and we export most of our coal to the other parts of the planet. Coal gives us most of the electricity that's produced here in the U.S. and in other places as well. Coal's been mined for more than 1,000 years. We do use surface and subsurface mining. Surface is safer, it's more cost effective, but there are times when we can find more coal reserves if we do a subsurface mine like a drift or a shaft mine. Deep sea mining is also big. However, there are issues that run along with deep sea mining. Obviously, the environmental side of it is also it's a very costly process with the amount of water and pressure that's over the mines that can be found in the ocean. Ownership comes into play, which are going to be deterrents for deep sea mining. So most of our mining, even though we do have deep sea, most of our mining is going to be land-based. And when you're looking at our mining process, most of our non-metal minerals is where we get most of our money from as far as value here in the U.S. Most of our non-metal minerals that we mine for are going to attribute to about $20 billion worth of revenue, whether that be coal, which is our biggest one. Coal is going to be our biggest one. It's our biggest exporter compared to our metal mining, which is usually gold, copper, silver. Now, there are certain things that are going to be in play when you reach a site, that's going to have an impact on how much mining can be done, and have an impact on whether or not you can mine at all within a certain area. And these impacts include the geology of the area where you're going to mine, the amount of material in that area that you want to mine for, the amount of mineral deposit, the depth of that deposit, the makeup of the surrounding rocks when you're trying to mine, the groundwater and soils that are going to be located around the mines that you're going to try to make, the type of mining method you're going to use, and the actual nature of the mining process. These are all things that can have an impact on whether or not mining can occur within a certain area. Then there's always problems associated with mining. The biggest thing is the overburden. Overburden is probably the biggest problem because you have a lot of excess rock and soil and crust from the earth that's going to be considered waste because you can't use it. Large holes in the ground, collapsing of the land if the mines aren't built properly, if there aren't structures to support the surface. If it's below the surface, then that can be an issue. Soil and water pollution from the types of materials used to extract minerals from ores. They're going to use things like cyanide and maybe arsenic, some other heavy metals to extract some of these minerals, and those can be turned into pollutants. And then just overall contamination from harmful substances, usually going to be talking about these heavy metals. Land reclamation is a big thing. Land reclamation is what the U.S. pushes. The government agencies push now to make sure that the land that we've used for mining processes, especially surface mining, whether it be open pit or strip mining, is changed back into or reclaimed into something that could be beneficial to us and the environment. And the way the land reclamation works is once you have a site that's completed, that site needs to be smoothed out. The soil needs to be dispersed evenly. Topsoil needs to be put down to allow the topsoil is going to be the key ingredient. It's going to contain fertilizers and things to allow for plant life to grow. And then replanting that plant life, replanting that vegetation to allow for the plant side of the habitat to regrow, and then that'll allow for the animal side to come in after. The big federal law, the U.S. regulates this stuff by the Federal Surface Mining Law. It was established in 1977. Pretty much it's making sure that we have the least effect possible on the land from mining processes. It also regulates the coal mining industry in the U.S., making sure that the coal mining industry has the smallest amount of effect possible on the land when coal mining occurs, since that is our biggest mining profit. There are regulations for mining. Make sure that the waste is disposed of properly. Make sure the water is clean. Water has to be used in a mining process. It helps keep dust down, which can turn into a pollutant. It helps keep equipment cool when drilling processes occur. And so water is going to be used, and so I need to make sure that the water is clean before it is put back into the environment. And then once the mining site is finished, that mine is going to be reclaimed for other uses. Mineral conservation is always a big push because obviously we've been using minerals for all kinds of things, and so we're getting to the point to where we're reusing them faster than they can be reformed naturally. So our minerals are going to be considered non-renewable because even though they can form naturally, it takes a long time, and we're using them faster than they can reform. So mining conservation is becoming a big thing. Some of the strategies that we put into play for mining conservation would be these three: substitution, recycling, and taxation. We try to substitute things. So instead of using metals for, say, for example, building materials, we try to substitute plastics instead. So using a substitute to conserve our minerals. Recycling. Recycling is also, there's a big push in that. Recycling metal scraps from buildings. Recycling, for example, aluminum cans to reuse them in other ways. So we're not using new resources, we're reusing the ones that we don't need and that we're not using anymore. And then taxation is a big one. There are economic incentives, monetary incentives to encourage conservation through these mining companies and through businesses to try to reuse things instead of going out and supplying new minerals or things made from new minerals. Just some